We're in sixth grade, lesson 16 today. I know we usually have tests after about every 5 lessons, so if you're following on your book, like there's supposed to be a test, we're going to do that one on Friday. We always test math on Friday, so we'll get a few more lessons ahead and then we'll go back. Hopefully you're done with the quiz. Get in the habit of this. Front side, you did Power Up D, you reduced fractions today. It's the first time that we've done this reducing fractions, so I'm going to read the answers so that you got the correct answer this first time. And then you can use that to check your answers if you need to, or to verify that you know what you're doing with reducing fractions. So reading across, I'll just go in order. 50 over 100 reduces to 1/2. 4/16 reduces to 1/4. 6/8 reduces to 3/4. 8/12 reduces to 2/3. 10 over 100 reduces to 1/10. Next row, 8/16 to 1/2. 20 over 100 to 1/5. 3/12 to 1/4, 60 over 100 to 3/5, 9/12 to 3/4. Third row, 6/9 to 2/3, 90 over 100 to 9/10, 5/10 to 1/2, 12/16 to 3/4, 25 over 100 to 1/4. Final row, 4/10 to 2/5, 4/6 to 2/3, 75 over 100 to 3/4, 4/12 to 1/3, 6/10 to 3/5. While I'm rattling off answers, I'll see how you did on the mental math. A, -10. B, $1.50. C, 82 cents. D, 92. E, 125. F, 1/6. Algebra, multiply by 3 gives me 6. All kinds of math, but it said start with 2 score. 2 times 20 is 40, and 10 is 50. Divide by 2, 25 times 3, 75 minus 3, 72. Divide by 9 is 8, plus 2 is 10. Divide by 5 is 2. Challenge problem says, can you please figure out the pattern? 1/6, 1/8, 1/16, 1/8, 3/16, 1/4. If you know your inch ruler really good, I think it was page 56, would have gave you the next ones right in order on your inch ruler. But guys, from yesterday's lessons, if we find equivalence, this is still 1/16. This is 2/16, 3/16, 4/16. So the pattern is going up by 1/16. So it would be 5/16, 6/16, 7/16, 8/16. This is good. This needs to be reduced to 3/8. This is good. This needs to be reduced to 1/2. So yesterday's lesson did a really good job of getting us prepared for that, finding equivalent fractions, and then helping us be able to reduce fractions. Okay, today we're moving on with what we call the U.S. customary system. All the measurements that America uses, because we're so stubborn to switch with the rest of the world. Almost every country in this world, guys, uses the metric system. I think there's a total of 4 countries only in this whole world that is still running on our U.S. metric system. Ours makes math difficult. Metric system, everything is the power of 10, so it's real easy to convert between them. Ours, you know, and you'll learn again today, not that easy to convert because you have to know all the different numbers that go along with it. Those numbers are in your yellow folder in 2 different places that I'll show you as we work our way through that today. So lesson 16 reads like this. In this lesson, we will consider units in the U.S. customary system. We can measure an object's dimensions. What are dimensions? Weight, volume, or fill in your blank, guys. That's temperature into your yellow folder. Each type of measurement has a set of units. We should remember common equivalent measurements and have a feel for the units so we can estimate measurements reasonably. The following table shows a common weight equivalences in the U.S. customary system. So they gave you box number 1, which says 16 ounces in 1 pound, and then 2,000 pounds is in a ton. So there's 2 goals. Number 1, I know how to convert these, and number 2, I have what they call the feel for this. So I can say, hey, a car weighs about a ton. A pickup truck weighs about 2 tons. Newborn baby weighs about 8 pounds. I have to have a feel like what would be a good estimate, and we'll get a few problems that go along with that. So guys, if you're in your yellow folder, you see how I took today's lesson and put the boxes that they're going to give us in here. But if you turn, it's a little more than half, but it's about halfway through this yellow folder, guys. You switch from all the lessons, so after lesson 120 here, the last one in the book, then you get stuff that Saxon Math gave you, and these are your measurements. So if you ever forget some of the conversions, they're spelled out for you here in nice little charts that you can use. So maybe you want to put a paper clip in here so that you can find this thing really quick to do the U.S. customary measurements. Okay, we're going to go through the different measurements and then get a problem or two from each one, whether it's temperature or weight or measurements. So number one says, suppose a pickup truck can carry a load of a half a ton. How many pounds is in the pickup truck? Well, guys, your chart says a ton is worth 2,000 pounds. So what's a half a ton? I have to take 2,000 pounds and I have to cut it in half, or I have to divide by 2. Well, 2 goes into 2,000 1,000 times. And so my answer is 1,000 pounds. And the label for pounds is LBS, because that doesn't make any sense to us, but guys, that's the reality of the abbreviation. Okay, top of the next page, it says here are your measurements. The following table shows the common length equivalents in the U.S. 12 inches in a foot, 3 feet in a yard, 1,760 yards in a mile, which is 5,280 feet in a mile. And so we have those conversions we have to do. The first question is, 1 yard is how many inches? Well, that's not on my chart, guys. My chart said 1 yard equals 3 feet. So I know that there are 3 feet in 1 yard. I also know that there are 12 inches in each foot. So I need to take 12 times 3 and get 36. So there's 36 inches in 1 yard. Now if you're back in your yellow folder, guys, you had this chart over here, but down here it says that for me. 1 yard equals 36 inches. So sometimes this back thing gives me a little bit more information than the front of my book did, and I wouldn't have to do any math if I remember that. Okay, so we got our conversion. Example 3 says a mountain bike is about how many feet long? So this is the, can I get a feel for what the length of a bike is? And I, in my head, said my bike is about as long as I am tall, and I'm about 6 feet tall. Okay, if you wrote down 5 feet, I'd let that go. You wrote down 7 feet, I'd probably let it go. You wrote down 12 feet, no, that's not even close. No mountain bike's 12 feet long. You wrote down 2 feet, not a mountain bike, right? That's a little kiddie bike. And so you got to make sure you're ballpark. It's an estimate, guys, but estimates need to be close, so make sure you're in the ballpark. Continuing on after example 3. Just as an inch ruler is divided successively in half, so units of liquid measures are divided successively in half. Half of a gallon is obviously a half gallon. Half of a half gallon is a quart, half a quart is a pint, half a pint is a cup. The capacity of each container above is half the one next in the line to its left. On the top of the next page, the following chart shows some equivalent liquid measurements that the U.S. uses. So I have 8 ounces in a cup, I have 2 cups in a pint, 2 pints in a quart. There are 4 quarts in a gallon because there's 2 quarts in a half gallon and 2 half gallons in a full gallon. Example 4 says, Steve drinks at least 8 cups of water a day. How many quarts does he drink? So I got 8 cups. I chop that in half, divide by 2 would give me 4 pints. There are 2 pints in every quart, so I divide that by 2 and I get 2 quarts. If I was in my sweet yellow folder, I would be up here counting cups. I get those little letter C's. I'd say 1, 2, 3, 4 in 2 pints, and there are those in there. So if I have 2 quarts, that would give me all 8 cups. So guys, once again, this thing in the back of your yellow folder might be beneficial. We solved it in 2 math problems. There you could have used a little picture to figure it out. And then it says the following shows the system of U.S. customary temperatures. 32 degrees is at water freezes. The average classroom's at about 70 degrees. They said 68. 68 in the winter, probably 70 something in the summer because you won't pay too much air conditioning. The average body temperature is 98.6. That's becoming more important today when we test for COVID everywhere. And the water boils at 212. Example 5 says how many degrees are there between freezing and boiling? Boiling is 212 degrees. Freezing is 32. I want to know the difference. That means subtraction. 2 minus 2 is 0. Cross, borrow, 11 minus 3, 8, 1 minus nothing, 1. There's a 180 degree difference between the temperature at which water boils and water freezes. We're going to use that later on this year when we convert from Celsius to Fahrenheit. We'll see the importance of that. Okay, so that was the first half of our lesson where we were dealing with the U.S. customary system. The second part of the lesson is function tables. Functions is kind of like sequences, guys. A function is a mathematical rule that identifies the relationship between 2 sets of numbers. The rule uses an input number to generate an output number. For each input number, there is one and only one output number. The rule for a function may be described with words or an equation, and the relationship between the set of numbers may be illustrated in a table or in a graph. In this lesson, we will use function tables to help us solve problems. We will also study function tables to discover the rules of functions. Example 6 says this table shows the weight of ounces for a given pounds. A, describe the rule. B, Maddie weighed 7 pounds when she was born. Write a function, we'll see how many ounces that is. So guys, I'm over here. 1 pound, 16 ounces. 2 times 16, 32. 3 times 16, 48. 4 times 16, 64. 5 times 16 is 80. So step 1, A said describe the rule. It is times 16. So now they said, hey, what's the answer when it's 7? I don't know, let's do 7 times 16. 7 times 6 is 42, carry the 4. 7 times 1 is 7, plus 4 is 11. So she weighed 112 ounces, abbreviated OZ, to get our answer. Example 7 says this. Hannah bought 4 yards of fabric to make a costume for a school play. Make a function table that shows the number of feet output given for the number of yards input, and use the function table to find the number of feet that Hannah bought. So guys, here's my function table. They said stick in your numbers for the yards and tell me how many feet they are. Well, from the beginning of this lesson, we learned that there's 3 feet in a yard. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, which was the second question. They said make a chart and then answer how many feet did Hannah buy. Hannah bought 12 feet. Now notice, guys, I don't really need to do labels down this because they're labeled up here in yards and feet. So it's just a sequence as a function table to be able to do those things. All right? Our U.S. customary system, guys, keep working at it. You've got to memorize those numbers that you multiply. I need to know 12 inches in a foot, 3 feet in a yard. I need to know 16 ounces in a pound, all that stuff. You got to have it up here to be good for math as we go through that. Okay? I'll see you on the iPad for lesson 16. 6 right here, we get going on number 1. It says 44 of the 193 flags of the countries around the world do not feature red. How many do have red? Well, if there's 193 total and 44 don't, we want to figure out how many do by subtracting that. Gives me a 9, I'd cross that out, made an 8, gives me a 4, gives me a 1. 149 flags do have red in them. Number 2, at Henry's Egg Ranch, 18 eggs are packaged in each carton. How many cartons would be needed to get all 4,000? I'm taking 4,500 total eggs, and I'm dividing it into packages of 18. So 18 goes into 45 twice. That's 36. I subtract. I get a 9. Bring down a 0. 18 goes into 95 times. That's 90. I subtract. I get a 0. I bring down. 18 goes into 0 times. So I need 250 cartons. From the page in my math book, number 4. If a coin is flipped once, which outcome is more likely, heads or tails? It's a trick question, guys. They are equally likely. Then it says, explain your answer. You could say 50% chance for each one. You could say 1 head and 1 tail. Those equal each other, so they need to equal each other, so they're equally likely. Number 7, write each number as a reduced fraction. The first one is 8/12. I divide the top by 4 because I divide the bottom by 4. It gives me a 2 and a 3. The next one for number 7 is 40%. I write it as a fraction, 40 over 100. I cross off my zeros because there's one on the top and the bottom. Divide by 2 is 2. Divide by 2 is 5. And 6 and 10/12. Divide my fraction by 2 gives me 5 and 6. My whole number stays with it, 6 and 5/12. We're going to get a lot of practice on the reducing fractions until it just becomes really automatic for us. Number 10, what percent of a yard is a foot? I know there are 3 feet in a yard, and I have what percent of a yard is a foot. So I have the fraction 1/3. If you have it memorized, you know that is 33 1/3. If not, guys, you have to say, I know percent is out of 100, and I'm dividing it into 3. So that goes in there 3 times, that's a 9, subtract, it goes in there 3 times, that's a 9, subtract, and I get 33 1/3%. Memorize that one so we don't have to do the math. 1/3 is 33 1/3%. What fraction of a gallon is a quart? I know there's 4 quarts in a gallon, and I have 1 of them. That one was nice, I didn't need to change it to a percent, so it's just 1/4. Number 11, the number 630 is divisible by which single-digit numbers? So I have 630. 1 goes into it because 1 goes into everything. 2 goes into it because it's even. 3 goes into it because 6 plus 3 is 9, and 9 is divisible by it. 4 does not go into it. I check it with the last 2. I know 4 doesn't go into 30. 5 goes into it because it ends in 0. 6 goes into it because of the 2 and the 3. 7 goes into it because I know the math right now, guys. I see that 7 goes into 63 9 times. It goes into 0, 0. 8 says check the last 3. So I'd have to do the whole number because it's only 3 digits. That would go in there 7 times. It would give me a 56. Give me a 7. It does not go in there evenly, so it's out. 9 goes into it because 6 plus 3 is 9. So you have your answers of 1, 2, 3, 5, 6, 7, 9. Number 13, which properties are used to illustrate these equations? The first one I have 1/2 times 2 over 2 equals 2/4. This is the number 1. Multiplying by 1 is the identity. The next one is 1/3 times 3 over 1 equals 1. If it equals 1, guys, that's the inverse property, multiplying by the reciprocal. Multiply by 1, identity equals 1, inverse. They're going to continue to pound that into our heads. 14, I am missing the first in subtraction. If I'm missing the first in subtraction, I add. So I have 1776 plus 87. Gives me a 3, carries the 1, gives me a 6, carries the 1, gives me an 8, gives me a 1. 1863. They're hoping you instantly went to a history lesson. Our country was founded. Abraham Lincoln gave a famous speech that says 7 years ago. That's 87, guys. This is the Gettysburg Address during the Civil War. His famous speech is a math problem right there. Flipping your answer key over, we're up to number 17. Missing something in multiplication, I divide. So I have 1,764 divided by 42. This goes in there 4 times. Multiply is an 8, multiply is a 16. Subtract. Gives me an 8, bring down the 4, goes in there twice. That's 84, problem solved. It's a perfect square of 42. Number 21. I have 4/3 times 3/2. Anytime the same number's on the top and the bottom, I can cross it out and leave 1s. 2 goes into 4 twice. 23. I'm taking 8 and dividing it into 100. Goes in there once. 8 subtract 2 goes in there twice. 16 subtract 4. I have 12 4/8, which reduces to 12 1/2%. 24, a big division problem. 9 goes into 70,000. You're going to see a little pattern here when we divide by 9s. Goes in there 7 times is 63. Goes in there 7 times is 63. Goes in there 7 times. Goes in there 7 times. Going to have leftover of 7. So I stopped doing it, guys, because when you divide 9 into the number, it repeats it. Okay? Number 26, describe the rule of the sequence and find the next 3 terms. So if I am quick on my feet and thinking really carefully, guys, it's my challenge problem solving from page 107 that we did in our power up. So I see that they have to describe the rule. The rule is by adding 1/16. So the next one would be 4/16, which reduces to 1/4. 5/16, which can't reduce. 6/16, which reduces to 3/8. So we did that one on problem solving, guys. That's why I didn't spend much time on it. It's just a matter of recognizing that. 28 says two walls representing planes. So I got wall number 1. I got it being intersected by wall number 2 here. Meet in the corner of the room. The intersecting of two planes is this. Now, guys, remember, planes go on forever, so I need to go on forever. Well, that is definitely called be a line. 29, find a fraction equal to 2/3 that has the denominator of 6. So 2/3 times I don't know gives me something with a 6. That makes the I don't know 2. 2 times 2 is 4. Add to that 1/6, and the sum is 5/6. Awesome. Feel free to do the other 15 for extra credit. Keep practicing math as we get to these tests. They have a major impact on your grade.